I am Archana Ubale, Department of Electronics and Telecommunication, ASSMS IIT Pune. We are going to explain here two-port network. First we see the objective of two-port network, that is to understand the port network and its function, to understand the difference between Z parameter, Y parameter, T parameter and terminated two-port network, to investigate and analyze behavior of the two-port network. Two-port network is a pair of terminals through which the current may enter or may leave. A network is known as port. Two terminal devices or elements such as resistor, capacitor, inductor results in one port network. Most of the circuits have dealt with two terminal or one terminal network. A two-port network is an electrical network with two separate ports. One is input and other is the output. The two terminal pairs acting as the access point, the current entering one terminal of the pair and leaves in the other terminal of the. So we can see in this diagram that the first diagram is the one port network consists of only one port, and in second diagram two port network consists of one input port and another is the output port. Two port network, what is the reason to study that? The network are useful in communication, control system, power system and electronics. Knowing the parameters of the two-port network enable us to treat it as a black box when embedded with a large network. For the network, we can observe that there are four variables that are I1, I2, V1, V2, which two are independent. The various terms that relate this voltage and currents are called as the parameter. So today we are going to see here the Z parameter. Z parameter also called as the impedance parameter and the unit is ohm. Impedance parameter is commonly used in the synthesis of filters and also useful in the design and analysis of impedance matching network and power distribution network. Two-port network may be voltage driven or a current driven. Two-port network in the first diagram that shows by the voltage driven and second as the current driven. The black box we replace by the Z parameter, so that you can see here Z11 and Z21 as the input port impedance and Z12 and Z22 output port impedance. The terminal voltage that is related with the terminal current you can see in the equation number 1 and 2. So we see the equation number V1, that is Z11 I1 plus Z12 I2, and equation number V2, that is equal to Z21 I1 plus Z22 I2. And this equation, if you write in the matrix format, we are getting this. So Z parameter that we want to determine are Z11, Z12, Z21, Z22. The value of these parameters when practically is calculated, that you require to set the first condition that keep the input port open, means I1 is equal to 0. In second condition, keep the output port open, means I2 is equal to 0. So from that condition you get these four parameters values using these formulas. So Z11 is open circuit input impedance, Z12 is open circuit transfer impedance from port 1 to port 2, Z21 open circuit transfer impedance from port 2 to port 1, Z22 open circuit output impedance. So here we are going to solve one numerical for calculation of Z parameter, and same circuitry we are going to simulate on falstad software. So here from this numerical applying KVL, we have calculated Z11, Z12 and secondly Z21 and Z22. So here we can see these values of Z parameters, and then we are going to verify these parameters by using simulation software falstad. So first is calculation of Z11 and Z21. So in this, these are the simulated circuit. In that circuit, when you calculate the Z11, so Z11 formula is here calculated, that is equal to, in the first condition, Z11 is equal to V1 by I1. So here value of the V1, that is Vd, is equal to 10 volt and I1 is 666.66 milliampere. And when you put these values in the formula of Z11 is equal to V1 by I1, you are getting the 15 ohm Z11 value. Then secondly, for calculation of Z21, The formula is V2 by I1. So V2 value here is 3.33 divided by I1 is 666.67 milliampere. Then by putting these values in formula, you are getting the value of Z21, that is the 5 ohm. So when you verify these values of Z11 and Z21 which we have calculated in last numerical, that you are getting the same. The next condition for calculation of Z12 and Z22. In this second condition, here we keep the first port open and connected the supply to the second port. So Z12 formula is V1 divided by I2. So what is the voltage here? And V1, that is equal to 1.25 divided by the I2. I2 current is flowing through the circuit is 250 milliampere. When you put these values, you are getting the 5 ohm Z12 value. And for calculation of Z22, formula is V2 by I2. So V2 here, that is 5 volt divided by the I2 is 250 milliampere. And put in that formula, you are getting the 20 ohm. So these all the 4 Z parameters, by using this simulation, we get verify that after simulation we are getting the Z parameter value that is same as the we calculated value previously. Thank you.